Hello student, welcome to our lesson today. We are going to continue with the determination of refractive index, and in this case or in this lesson we are going to look at refractive index in terms of velocity. Now light travels faster in an optically less dense medium than in an optically denser medium. So if we consider a ray of light that is crossing the boundary from medium 1 with velocity v1 to medium 2 with velocity v2, where v1 is greater than v2, we have the diagram as shown here. This is how the ray of light is going to behave as it crosses this medium 1 to medium 2. There is change in direction. Now, the refractive index of medium 2 with respect to medium 1 will be given by sine I, this one, divided by sine R, this one, which is the same as V1 over V2. In other words, we are saying the refractive index of medium 2 with respect to medium 1 is equals to velocity of light in medium 1 over velocity of light in medium 2. But when we come to absolute refractive index n, this one is defined as the refractive index of the medium when light is traveling from a vacuum to the medium. So mathematically, we can say that this absolute refractive index is equals to velocity of light in vacuum divided by the velocity of light in medium. So having this in mind, then we can consider C as the velocity of light in air, then V1, the velocity of light in medium 1, with the refractive index of n1, and V2, the velocity of light in medium 2, of refractive index n2. Then n1 is equals to velocity of light in air divided by the velocity of light in medium 1. That is by definition. Then n2 will be velocity of light in air divided by the velocity of light in medium 2. So if we take these two terms and we divide, that is n2 divided by n1, you will get that the value will be, remember here we are dividing, so we multiply by the reciprocal. And when you multiply by the reciprocal, you will find that these two terms are common, so you cancel out. You will be left with the velocity of light in medium 1 divided by the velocity of light in medium 2. And by so doing, we say that n2 over n1 is equals to v1 over v2. But we have seen previously that v1 over v2 is a refractive index of medium 2 with respect to medium 1. Now we can consider this diagram where I is equals to theta 1 and R is equals to theta 2. If you want to get the refractive index of medium 2 with respect to medium 1, this will be given by sine theta 1 over sine theta 2. But now, this refractive index of medium 2 with respect to 1, we have seen here that it is the same as n2 divided by n1, which is the same as v1 over v2. Now, this one can be simplified as we are going to see in this slide. We have that when you take sine theta 1 over sine theta 2 is equals to n2 over n1, you can cross multiply. And by cross multiplication, we get n1 sine theta 1, which is equals to n2 sine theta 2, which implies that n sine theta is equals to a constant. And this one is simplified way of Snell's law. Therefore, the product of refractive index of a medium and the angle a ray makes with the normal in the medium is a constant. And that constant, you can be able to get it. We look at an example. Given that the refractive index of diamond is 2.51 and the velocity of light in air is 3.0 times 10 to the power 8 meters per second, calculate the velocity of light in diamond. We proceed as follows. We start by writing the formula. That is, refractive index of diamond is equals to velocity of light in air over velocity of light in diamond. Now, substituting the values, the refractive index of diamond is given as 2.51. The velocity of light in air is 3.0 times 10 to the power 8 meters per second. So what we are looking for is the velocity of light in diamond. So we can make it the subject of the formula by multiplying through and then dividing by 2.51. And by so doing, you get that the velocity of light in diamond is 1.15 times 10 to power 8 meters per second. That is 1.195 times 10 to power 8 meters per second. That is the velocity of light in diamond. Then we proceed to our second example. Given that the velocity of light in water is 2.27 times 10 to power 8 meters per second, and in glass is 2.1 times 10 to power 8 meters per second, calculate the angle of theta below. We have the diagram here. We have the theta and we have this angle. You need to be very careful because the angle that is given here is not the angle of refraction. Remember, by definition, the angle of refraction is the angle between the refracted ray and the normal. But this angle is between the horizontal line and the refracted ray. So you need to calculate or to get the value of the angle of refraction. And how do you do it? You get the value of 90 degrees, you subtract 68 degrees. So we proceed as follows. Sin theta 1 over sin theta 2 is equals to V1 over V2. This should be V2. Then sin theta 1 is what we are looking for. But theta 2 is 22 when you subtract. So it will be sin theta divided by sin 22 is equals to 2.27 times 10 to power 8. That is the velocity of light in water divided by velocity of light in glass, which is 2.1 times 10 to power 8 meters per second. Then after that, when you multiply all these terms and then you get the sign inverse, then you get the value of theta as 23.88 degrees. Then from there, we have the assignment. The assignment is just testing what we have just learned. So make sure that you attempt all of them and get everything. So thank you, and let us meet in our next lesson.